are FDP, and FDP is based on statistical tools using SPSS. So for today's session, we have joined with Dr. Priyanka Chawla, ma'am, Delhi College of Business Management, Indore, and Dr. Sameer Dubey, Associate Professor, Acropolis Institute of Management Studies and Research, Indore. So, moving ahead, we are just going to start the session. But before that, I am very happy that I am going to introduce our today's speakers. So, I would like to introduce our speaker. And now, first speaker I am taking here is Dr. Priyanka Chawla, ma'am. Dr. Priyanka Chawla, ma'am, is a finance personnel with 11 years of experience in academic domain. Qualification includes MBA Finance and PhD in Management. She has submitted the report of postdoctorate to ICSSR New Delhi. She has attended many conferences, workshops, and FDPs. She has published 2 books and got more than 30 papers in her credits. She has been invited as an expert in various organizations and delivered many lectures on based on ICT, RM, and SPSS. Presently, she is associated with Delhi College of Business Management. She has been recognized with various awards. Recently, she won the Best Research Paper Award in an international conferences organized by PIMR Indore. Now it's time to introduce our second speaker, Dr. Sameer. Sir is having 17 years academic and 4 years corporate experience. At present, he is working with Acropolis Institute of Management Studies and Research, Indore, as an associate professor. He is having more than 30 national and international publications in research journals and conference proceedings. He has a case study published by European Case Clearing House to his credit. Dr. Dubey has also co-authored a book named Banking Law. Dr. Dubey is a member of MP Economic Association and Research Foundation of India. He has been invited as a speaker in many organizations and institutes and in many events. So this is all about the introduction of our today's dignitaries. And now, firstly, I would like to invite Dr. Priyanka Chawla, ma'am, to take this session ahead. To start the session.
Sir, ma'am, Dr. Dubey sir will be starting the first session, and then I'll be taking. So I think he has not joined yet, but I have messaged him.
Dr. Priyanka Chawla, ma'am.
Ma'am, is my voice audible?
Yes, ma'am, session, you can start now.
Ma'am, first session will be taken by Sameer sir, and then I'll be taking the next session.
Just a minute,
So
ma'am.
I have messaged him to join the meet, Google Meet. So I think he will be available within 2 minutes. Sameer sir will be available.
Ma'am, actually, I think there is some problem in from my side. So just give me 1 minute. I am getting login through my mobile.
Okay. Today is the part of EFA, exploratory factor analysis. The theoretical part will be explained by Sameer sir, and the demonstration will be explained by me. So just give me 2 minutes. He will be joining. I think sir has joined. Sameer sir, are you there?
Samir sir. So ma'am,
Yes, ma'am.
yes sir. So sir, are you ready for the session?
Yeah, sure, ma'am. Just
Okay,
give
sir.
me a second.
Yes, sir. Yes.
Actually, some just adjustments I need to make, and I'm all set and done. Okay, sure, ma'am. Now we can carry forward.
Yes, sir. Sure, sir. So would you like to share some PPT?
Yeah, sure. I'll be sharing the PPT over here.
Yes, sir.
So, good evening, everyone. Today, the session, I believe the brief of the session would have been given by Priyanka Chawla, ma'am. So, here we are starting off with today's presentation. And so now whether the PowerPoint presentation is visible to everyone?
Yes, sir. Visible.
Okay, thank you so much, ma'am. Okay. So today we are going to discuss about factor analysis. What exactly is the meaning of factor analysis? We'll start up from there only. So I believe some of you people would already be knowing about what exactly is a factor. So we are starting off with the factor analysis, and what exactly is factor analysis is like, let me take an example of like the one for which actually we are doing all these things. Whenever we do research, what happens is we used to collect a lot of data, because data is everywhere. All our research nowadays is completely dependent upon data analysis only, and data is everywhere. Wherever you go, you will find either we are going for primary data, secondary data. We are all for all whole this throughout this whole workshop, we would only be discussing about data only. So we have this qualitative data, we have quantitative data. So data is everywhere. Data basically nowadays, like in technology as well, now we are having artificial intelligence as well. So data has really become very essential, not only for the purpose of business, but it has nowadays become an essential commodity as well. And this commodity is basically why this is perceived as a commodity, means this is perceived as a link between the present and between the past and the future. So this is the reason why an organization is always willing to collect its records, why the organization is always willing to analyze its past records as well. So data is basically, it is a key solution to the problem of connecting the past to the future or predicting the future. So whenever there is some kind of, like, you might have regularly been hearing about certain words like machine learning, like algorithms and all these things. So all these things are basically data analysis only. So whenever it comes to a data, there are lots of tools and techniques are put to work. They are put to work, and the work is basically to arrange the data, to organize the data, for accumulation of the data. And factor analysis is basically one of these techniques, where what we do is basically we use to reduce the data. So factor analysis is basically, it is a technique through which we are reducing the data. We would be having a lot of data with us, but everything that we have collected might not be of very much utility for us. So what we do is we use to reduce the data, we use to narrow down this data, and then we use it. Because if suppose in researches as well, we people used to collect primary data with the help of questionnaires in general, and we collect a lot of data definitely, depending upon how many questionnaires you would have got. But what we do is we collect data from almost 300, 400, 500 questionnaires, and we get a lot of data. Suppose your questionnaire, each questionnaire is containing somewhere around say 50 questions or so, and we are collecting data from 500 respondents. We used to get data for about 2500 questions. So this is the reason, 25,000 questions. So what happens is we get a lot of data from different sources, and factor analysis is basically a technique where what we do is we reduce the data so that we can make it analyzable. The factor analysis, what factor analysis do is, factor analysis reduces the data. Factor analysis makes the data analyzable for the researcher. Now, what are different types of factor analysis we generally use? So there are a variety of techniques that to conduct the factor analysis. Like there are principal component analysis, one of the techniques for factor analysis. Then independent component analysis, another technique for this factor analysis. And these basically are the two techniques which are most widely used. And apart from this, principal component analysis is most widely used technique for factor analysis. Otherwise, what we do is we used to differentiate, we used to classify factor analysis into three different parts. The first one is confirmatory factor analysis. In confirmatory factor analysis, what happens is, it actually, as the name suggests, confirmatory factor analysis lets the researcher determine whether a relationship between the factor or a set of variables and the components, whether this relationship exists actually or not. So it helps the researcher confirm whether there is a connection between the components of variables in a given data set. Usually the purpose with which we use to conduct confirmatory factor analysis is to test whether the certain data fit the requirements of a particular hypothesis or not. And I believe that this shall in detail be dealt in by tomorrow in confirmatory factor analysis session. So today we need to deal about exploratory factor analysis. And what exploratory factor analysis is? Exploratory factor analysis is basically, it is a statistical analysis. And the reason for this is to explore or to determine a structure of large set of variables. What we do in exploratory factor analysis? We tend to uncover the relationship. We need to, there are three different words: exploratory, factor, and analysis. So exploratory is we use to explore, and what we explore? We explore the relationship between factors. What are the factors? Factors that we form, and how the factors we form, that will definitely be theoretically and practically shall be explained to you. Theoretically, I'll be explaining you. Practically, with the help of SPSS, Dr. Priyanka Chawla shall be explaining you how we form factors. So what happens is exploratory factor analysis. First, we explore the phenomena, then we form factors with the help of the data collected, and then we analyze those factors so that whether the data fits in for the analysis of whether the analyzed data give us the required results that we are looking for or not. So this is what is known as exploratory factor analysis. And the second one analysis of second one and the last one factor analysis is called structural equation modeling. What happens in structural equation modeling is we used to explore different type of relationships between the data or between the factors that we have already formed. These kind of like certain relationships are like mediation, like moderation, even confirmatory factor analysis is also a kind of structural equation modeling. So there are different types of factor analysis. Apart from this, what happens is, like, there are different applications of factor analysis as well, where factor analysis can be applied for. So factor analysis can be applied in marketing. In marketing, to define the act of promotion of good or a service or even a brand. When it comes to factor analysis in marketing, we can say that one can benefit immensely from this statistical method of factor analysis. Why so? Because we used to collect a lot of data from regarding consumer satisfaction, regarding brand satisfaction, regarding brand loyalty. And what we do is, we used to collect data. Our respondent, the customer, the people with whom we are dealing, they should not know what exactly we are collecting, why we are collecting what kind of data we are collecting to. Otherwise, what will happen is that the collected data will include the biasness. So that to reduce that biasness, what we do is we make disguised statements. And with the help of those statements, what we do is we convert those statements into variables. We convert those statements into variables, and then variables into factors. So for the purpose of marketing, factor analysis is important for us. Then for data mining as well, factor analysis can play a very important role. It is as important as of artificial intelligence in current days techniques. So what happens is, in artificial intelligence, in data mining as well, they get a lot of data. They get a huge data set, and then the work of grouping that data set is being conducted or being done by the help of factor analysis only. So for data scientists also, the finding of relationships and establishment of correlation among different variables, it is very important, and this work is being done by factor analysis. Then there comes machine learning as well. Machine learning and data mining tools go almost hand in hand. This might be one of the reasons why factor analysis plays a very important role in machine learning tools and techniques. So the factor analysis, in the area of machine learning, factor analysis helps in reducing the number of variables in the collected data set, so that you can procure accurate and enhanced set of observed factors. Various machine learning algorithms are also put to use to work accordingly, just as per depending upon what kind of data they have got. So this is what is known as this is the importance of factor analysis in machine learning. Then there comes nutritional science. Nutritional science is basically, it is a contemporary scenario. It is really a very important. It is a important and upcoming field in which focusing on the dietary practices of a given population, factor analysis used to help to establish relationship between the consumption of a specific type of nutrients in adults, in child, or in whatever the respondents you got, and the nutritional health of that person. So how the nutrients you are consuming and how they are affecting, those nutrients are affecting the health of that specific person. This relationship can easily be determined with the help of factor analysis. An individual's nutrition intake and constituents health status have helped nutritionists actually to compute the appropriate quantity of nutrition that one should take. Because it happens that at times you might either be taking too much nutrients, or you might not be taking any nutrients at all. So this actually helps. Then there comes the most awaited and most widely used area of factor analysis. That is business. In business also, factor analysis is very much helpful. The application of factor analysis is really very, like, it is not only surprising but very satisfactory as well. I believe there was a time when actually firms used to employ professionals so that they can find out the patterns from past records in order to lay a record ahead for strategic business plans, because they need what has happened earlier. Very simple thing in business, what they used to call is history repeats itself. So the purpose of making strategic business plans, what they require is the decisions taken earlier. They used to collect the data, what kind of decisions people have taken, how the decision has resulted in how the performance has increased or decreased, or has been become better or inferior with the help of specific kind of decisions taken by the authorities at that time. So definitely the factor analysis is helpful for all these things. Then there comes exploratory factor analysis. I believe you people can see the balls over here. Everybody can see the balls present over here. I feel you people can see the balls in the picture.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Now there is a small video I would like to play for you, and I feel that it would be easier for you. So I am playing a small video for you people. Please see it. It does not contain any kind of voice, so you might not be actually listening to anything. But that video is actually only for the purpose of understanding what factor analysis and exploratory factor analysis used to do for a researcher. So here I am sharing this with you people. Okay, can you see it is Galton box simulation?
Yes, sir. Yeah.
Now it's
Okay,
visible.
it is visible to everyone. I have not yet started it.
Yes, sir. Visible, sir. Visible.
Okay, so now I am starting it. I hope you will easily understand the meaning of exploratory factor analysis, which I wanted to tell you.
Excuse me, can you speak in a bilingual?
Sure, why not? That also can be done.
Please, sir. Please,
Sure.
sir.
Okay. So here I am once again, I paused it, but now once again I am starting the video. Okay. Now can you see what is happening in the video? देख सकते हैं आप क्या हो रहा है वीडियो में? कोई एक्सप्लेन करके बताएगा मुझे वीडियो में क्या हो रहा है?
सॉर्ट हो रहा है.
ओके. देखिए काफी सारी बॉल्स हैं जो ऊपर से नीचे गिर रही हैं. ठीक है?
Yes, sir. Yes, sir. It's getting sorted out by colors variations also.
Exactly. Yes. Okay, here it ends. Now once again, there we are. And now just a second, let me present you to the, once again let us go back to my PowerPoint presentation. So now what you, if somebody can explain me what you understood. Anyone?
So the wholesome data, the data filtered into a group data.
Exactly.
It's a filtered one, so that we can easily talk about that.
Yes.
Understand
This is what actually is the purpose of exploratory factor analysis. For as a researcher, what happens is why we use exploratory factor analysis. there are only two basic objectives of a researcher, of an academic researcher. Okay, the first thing, I'm not talking about theory. In theory, definitely here it is. I'll be showing you that there are 4 different objectives of this data analysis, of exploratory factor analysis. What I'm asking, what I'm telling you right now is the practical reasons why we used to go for exploratory factor analysis. And there are 2 basic reasons only why we do factor analysis, exploratory factor analysis. The first one is either you are preparing a scale, either you are going to make a scale. This is one of the reasons why we make exploratory factor analysis. And the second reason why we do is just to re-establish that the factors that we already know, or to increase the number of factors. We are already having certain, say, if we are, because what happens in exploratory factor analysis, what we do is we used to start our study with the help of a theory. We start our study with the help of a theory. So we have a theory already. And then what we do is we used to re-establish that theory on certain new conditions, with certain new data set, with certain new responses at different point of time. Anything or a mixture of all these things can be done for exploratory factor analysis. This is why we use exploratory factor analysis in our research. So हम लोग जो एक्सप्लोरेटरी फैक्टर एनालिसिस यूज करते हैं वो इन्हीं 2 पर्पस में से किसी एक पर्पस के लिए यूज करते हैं. ठीक है, तो एक्सप्लोरेटरी फैक्टर एनालिसिस में हम लोग क्या कर रहे हैं, हम लोग क्या करते हैं, किसी थ्योरी के साथ में स्टार्ट करेंगे जहां हमारे पास 4 फैक्टर्स ऑलरेडी हैं. किसी फिनोमिना को एक्सप्लेन करने के लिए 4 फैक्टर्स वी ऑलरेडी हैव, और अब हम उस 4 फैक्टर से हमको ऐसा लगता है, एज पर आवर एजम्पशन वी फील ये 4 फैक्टर आर नॉट सफिशिएंट. So what we require more factors. We require, rather than 4, there should be 7 factors. I believe you people can remember the 4 P's and 7 P's in marketing. I believe you people remember?
Yes, sir.
Exactly. This is from where actually this exploratory factor analysis is used. Okay. So this was about exploratory factor analysis, what it is and what it used to do. Then definitely we are having objectives of exploratory factor analysis. A hand has been raised by Priyanka Bose. Is there any query? No. Okay, so we have 4 different objectives with for which we used to go for factor analysis. The first one is data reduction, as I explained to you, and development of theories. So what happens is how we used to develop theories. Like development of theory is really a very vast area, but how we develop or we contribute to for the development of theory is we used to collect the data. We used to collect data, and that data is in the form of raw statements. And this factor analysis used to help us in collecting those statements and make a specific factors. We reduce the data, we club those statements in the form of factors. The statements that we use for the purpose of collecting data is known as variables. I shall definitely be explaining different terminology as well, but in the meantime as well, I'm explaining the very same thing. Whatever is coming in between, I'm explaining those things. So definitely there is a complete list of all the things. So this is for the purpose of data reduction. Then the second one is for determining the strength of relationship between variables. What happens is we used to club variables. So for the purpose of making a factor that Dr. Priyanka would be showing you. But what happens is there are certain variables, and what we do is we used to club, we used to reduce the variables. How we used to reduce the variables? All the similar variables, as you saw in that video as well. All the different colored balls, all those balls were different variables. They were different statements. And what has happened in the last, that all of them have similar kind of variables have been sorted out. They have formed a specific group. So this is what we used to do, determine the strength of relationship. Whenever we calculate the strength of variables, actually the strength of variables or the strength of that specific factor making the variables is we used to do it with the help of factor loadings, which shall later on be explained to you. So that factor loading used to specifically say about the strength of that specific factor. Then it is useful for construct validity of scales and instruments. As I told you, if you are going to prepare or if you are going to make a scale, in that case the construct validity can be judged with the help of factor analysis. Then it is useful to address the assumptions that can guide suitability of data, whether the data is suitable for the research or not. So this is how these are basically the objectives with the help of which we can conduct exploratory factor analysis. Multicollinearity in multiple regression or multicollinearity. Actually, what happens is, what exactly multicollinearity is? Multicollinearity is basically a phenomena in which what happens is different variables depict the very same behavior. Very same behavior. So what happens in the very same behavior? What will happen is you just have to repeat the very same thing again and again. So what we do with the help of factor analysis, we used to club these kind of variables. Multicollinearity, basically it is correlation between two different variables. Very high value of correlation. So whenever see that the correlation between two or more variables is increasing, it has increased, it has surpassed 0.9 value. The very high degree of correlation, 0.9, it has surpassed 0.9 as well. So there are certain variables which are very much correlated, which are very much correlated to each other. So that even if you replace one of the variables, it won't help, it won't be of any means it won't negatively affect your research. So what we do is we used to club them. This is how the multicollinearity effect can be reduced with the help of exploratory factor analysis. Now there are certain key terminologies. Variables are basically the statements that with the help of which we used to collect the data is known as variable. These variables clubbed together, practical definitely be shown to you with the help of SPSS, we call it a factor. Then R matrix is basically a correlation between these different factors. Different variables. So this is basically a multiple correlation, as was yesterday asked, how we can calculate this multiple correlation. So that multiple correlation can be calculated over here. You will get a matrix for multiple correlation. You will have all the variables in column. You will have all the variables in rows, and there is a huge table showing correlation between these variables. So that R matrix is basically a matrix showing relationship or correlation between different variables. Then KMO and Bartlett's test. This basically is used for sufficiency of the sample size, sufficiency of the samples. Then factor loadings is definitely factor loading is basically we use to club different variables under one factor, so that we get there is another thing. There is another word that will be used over there that is known as Eigen Value. So Eigen Value is basically the contribution of each variable for the making of this factor. This is what that Eigen Value. So those Eigen Values are being clubbed together for the purpose of making a factor, and the stronger Eigen Value, the higher Eigen Value used to depict a strong factor. So that is what is known as factor loading. The clubbing of that or the adding those different Eigen Values is the process is known as factor loading. Then communalities. Communalities are basically, there are two different types of communalities. One of them is absolute communality, and the other one, I'm just a second, let me check that the value of that communality, what exactly we used to call it. I'm just skipping the name right now. Just a second. So we have absolute communality. One of them exactly is the absolute communality, and I'll just come back to you for in a minute or so. Somebody wants to tell me? Okay, I'll check it, and means in the meantime also it will come to, it is here only. It is, but unfortunately I'm unable to just tell what exactly is the word. Just a second. Okay, so here it will come, don't worry. So now the communality is over there, and then explain variance. Explain variance is basically, it is the total of the eigen values of the factors which are contributing highest, and the variables which are contributing highest for the purpose of explaining. Variance explained is how much variance in the phenomena can be explained with the help of the number of factors. That is we used to that is what we used to do. We also call it like R square as well. So that is what we used to say. This is what is known as explain variance. So the overall statements or the overall values, how much amount of variance in the phenomena or how much amount of variance can be explained, that is actually over there. So this is one, and then there comes scree plot. Scree plot is basically means variable variance explained is the model. What I wanted to say is that with the help of the model, whatever the variables or what are the factors you have identified, so those factors together, how much variance in the phenomena can be explained by these factors. Thus, this model is being explained in the explained variance table you will find. And then there is a scree plot. Scree plot is basically a graph with the help of which what happens is it is basically like that. This scree plot is based on rotated component matrix actually, and scree plot is basically the number of your factors are being shown over there. This is what actually is there. So this shall definitely be explained later on with the help of this, while calculating this, all these things with the help of SPSS. And then there is a small exercise. May I means this is the place from where the practical portion used to start. So may I now please Dr. Priyanka Chawla to continue from here. Dr. Priyanka over there.
Yes, sir.
So, ma'am, over to you from here.
Okay, sir.
Thank you so
Thank you,
much,
sir.
ma'am.
Sir has explained in a simple way what the EFA is, exploratory factor analysis is, and the key terminology is used in EFA. Thank you, sir. This is one example.
Priyanka, ma'am.
Sir,
Can
I'll
you
show my screen. Shall I show my screen?
Please, please.
Just a minute. So in short, EFA is, we are going to reduce number of variables, right? And we are forming one factor. There are n number of independent variables, and we are going to concise it. We are going to form it one in a factor, right? There are n number of independent variables. If there are n number of independent variables, even we can apply regression, but it gives a problem of multicollinearity. It gives a problem of autocorrelation. There might be other problems also. N number of independent variables will be there. So it is better to make a, it is better to compile it in one factor, right? So how can we do this? This is the example. Suppose a car company is going to launch SUV. New car is going to launch by a company that is called SUV. And what they are doing, is my screen share? Is my screen is in shareable mode?
Ma'am, your screen is visible, ma'am.
Suppose there is a car company which is going to launch a new SUV car. So it will collect data from the customers, and data will be collecting from 1 to 9 scale. Okay. Generally, we use 1 to 5 scale Likert scale, and this data will be collected from 1 to 9 scale, right? The dependent variable will be whether the customer will buy a new car. Will the customer will buy new car? This will be the dependent variable. That means why? Independent variable will be like this. X1 is independent variable. Good physics should be maintained. Dress for fashion. Have stylish clothes. Want to look different. Why you want to purchase a car? These are the independent variables. Like do not want to be a heavily in debt. Like to pay cash for purchase. These are n number of independent variables. Based on this variable, we calculate what is dependent variable, right? So either we can go for regression that sir has already explained, but these are, you can see these are 21 independent variables. These are 21 independent variables. Can we go for regression? Is it appropriate to go for regression?
No, ma'am.
So what we can do? The variables which are of same nature, the variables which are of same characteristics are come together in one factor, right? Right? What we do generally in class, when we take a lecture in class, we can see n number of students are there. Some are slow learners, some are brilliant, some are notorious, some are very, we can say, hesitations are also there. So what we do, the students of similar nature, we group together. Similarly, what we are doing, independent variables of similar nature, we are going to group together in factor, right? So how can we do this? I'll give you the demo of this. Let me open the data set. Just a minute. Yes. Can you see this data set? Yes, ma'am. So, why we purchase a car? This is dependent variable. We will purchase a car. Considering buying new car, this will be called as dependent variable. Now, there are n number of reasons we can purchase a car. It will be depend on good physical condition, for fashion, for stylish clothes, for looking different, self-confidence. There are n number of independent variables. So how can we run this factor analysis? Go to analyze. Can you see this? Dimension reduction. Dimension reduction. Under dimension reduction, Go to factors. Now, take this independent variable, starting from good physical condition till end. This one. I'm transferring all my independent variables under variable column. Now, under descriptive tab, click on, mark on KMO and reproduced. Click on continue. Under extraction tab, there are various methods like principal component method or maximum likelihood, right? Or principal excess factoring. Either we take principal component, generally we take principal component matrix, or we can take maximum likelihood or principal excess. These two are also famous one. So the basic one, by default, it is mentioned over here. Based on eigenvalues, by default, one is mentioned, so no need to make any changes. If you want, you can click on screen plot. Okay. Under rotation tab. Under rotation tab, the two famous methods are Varimax and Oblimin, direct Oblimin. So we can, or Promax also. These are the three methods we can use: Varimax, Promax, or direct Oblimin. So generally we take Varimax, continue. Under score tab, just mark on save as variable. Click on this, go to continue. Under option tab, this is very important. Sort by size and suppress small coefficient. This one is very important to mark, because if you will not mark on this, then you will not get proper matrix, pattern matrix. And the value below this need to be changed. 0.40 will not appear. We need value which are more than 0.40. Okay? Continue. And then go to OK. So now, generally we use EFA. Why we use EFA? For, as sir had said, for theory development. Right? Somebody else has not done any research. We are going to explore these things. So we are going to explore these things. That's why we are using this EFA. Once we done with EFA, we confirm the factor. That after EFA, after applying EFA, just to confirm the factor, then we go for confirmatory factor analysis, CFA. Now, after applying EFA, what things we need to report? The first one is KMO, Kayser-Meyer measure of sampling adequacy. KMO means it shows the sample adequacy. And it should be greater than 0.7. KMO means whether the sample is adequate or not. Right? So KMO should always be greater than 0.7. Next thing we have to report is Bartlett test. What is Bartlett test saying? Anybody who's having any idea about this? It shows the relationship, correlation between the variables. Is there any correlationship between the variable, relationship between the variable or not? If p-value is smaller than 0.05, that means there is a correlation. If correlation between the variable is not there, that means we cannot go for EFA. Right? Matlab, that means two things we have reported right now. KMO, which which tells us about the sample adequacy. Second thing is Bartlett test. It should be smaller than 0.05. Okay, which is showing that there is a correlation between the variables. The next thing is communality. Communality, we have to check this extraction part. Are you all there?
Yeah. Yes, ma'am.
Anybody who can tell about communality? What is communality?
It's partition, segregations of all the things, separating all the sectors, factors.
We can say that. We can say this one, but in simple language, if I say, if your supervisor is telling you to do that particular work, what will we do? Individually, you will give your 100%, right? So what communality is doing? Initial meaning means it is 1 means if individual, its value is 100%. But if it comes under the factor, then its value reduces. That means when we are working in a team, others are also contributing. So our part reduces. Similarly, communality is saying that individually it is giving 100%, but after extraction, its value reduces. That is 83%, 82%, 0.69, 0.441. Okay. So we have to take communalities above 0.4. The value communality should be greater than 0.4. Okay, that is good. In our data, the value is greater than 0.4. Another thing is total variance explained. Total variance explained means how much variance is explained, how much variance of dependent variables are explained by the model. So it is explaining 79%. Can you see this? This model is explaining 79%. How much it is not explaining? 100 minus 79. That means 21%. The model is not explaining. So we have to consider the value above 1. We have to consider the eigenvalue above 1. Can you see this? 0.786, 0.711, 0.555, 0.39. This should be ignored. Component from 7th item till 21 item will be ignored. Because the reason is the eigenvalue is smaller than 1. So we have to take the eigenvalues which are greater than 1. So with the help of this total variance explained, we can see that there are 6 factors which are found. There are 6 factors. This one, whose value is greater than 1. So 1.6, 2.009, 2.376, 2.416, 3.5, 4.7. So what we are doing? Initial eigenvalues are 4.7, 3.5, 2.4. So which is having weak factor. Which one is the weak factor? And which one is the strongest factor?
First one is the weak and 6th factor is strongest.
No, 6th factor is weak. First factor is strongest.
Okay.
We have to, what we are doing under total variance explained, we are removing the eigenvalues which are smaller than 1. So from 7th component till 21st, it is of no use. We are removing all these variables. That means there are 6 factors are formed. First, second, third, fourth, 5, 6. Because their eigenvalues are greater than 1. But the eigenvalue is saying that it is greater than 1. But it is smaller than 4.7. Can you see this? So this one is the strongest factor. This one, 4.717, 2.797, 2.7, 2.4, 2.3, and then come to last 1.6. So this is the strongest factor, followed by second factor, third factor, fourth, fifth, and this one is 6th factor. That means this 21 variables are combined together under these factors. Okay. And this total variance explained should be more than 50%. Now, it is of no use component matrix. Another thing is rotated component matrix. We have to report this one. Rotated component matrix means factor loading. This is showing factor loading. The factor loading is the relationship between factor and variables. Okay, these are factor loadings. And there should be no cross loading. With the help of this matrix, we can see that all the variables come under one head. This is first factor. The first factor is defining use of credit card, spend for day, like for pay cash, not heavily in debt, sudden use of coupons, interest rate are low. So this is forming one factor. This is forming one factor. After the factors are formed, we give names to these factors. When we give names to this factor, it is called latent variables. That we will be discussing tomorrow in CFA class. Second factor is, which was explaining how much total variance explained, which was explaining 2.79%. That means percentage of variance is 13%. First factor was explaining 22% of variance. It is the strongest one. It consists of 6 variables. These are the factor loadings. Okay. This first factor consists of 6 variables, 6 statements, or we can say, and these are the factor loadings. And when we form this first factor, it is explaining 22.46%. Then the second factor is this one, 0.719. Sorry, this is not this one. This one. The second factor is good physical condition, dress for fashion, have stylish clothes, look different. This 4 variables comes under the second factor. Now, based on this statements, we will provide nomenclature. We will provide names to these factors. Similarly, third factor is this one. It consists of 3 variables. Fourth factor consists of 3 factors. Fifth factor consists of 3 variables, and last 6th factor consists of 2 variables. Clear?
Yes, ma'am.
Now, this component transformation matrix. This shows that the value should not be greater than 0.5. Sorry, 0.7. Okay, that means it is sufficient. But generally, we do not report this matrix. Now, what if such KMO value or commonality, whatever I was saying earlier, what if these value does not come? That means there is a problem in your questionnaire. So we have to remove these engaged respondents. We have to remove these unnecessary respondents. So we have to clean the data, or we have to check the reliability. Achha, just a minute, one more thing. In this, we have formed 6 factors, right? The first factor is use of credit card while buying a car, spend for today, like to pay cash, not heavily in debt. Okay, these all variables comes under one head. That means we will have to provide the name. We will have to provide the name of the factor, of this factor, this first factor. So these variables are related to, can anybody guess? These variables are related to finance. So can we give the name of this factor finance? अगर आप कार लेना चाह रहे हैं तो क्या यूज करेंगे? क्रेडिट कार्ड से पे करना यूज करेंगे? हेलो हेलो
Ma'am, yes, ma'am.
Yes, ma'am.
अगर आप कार लेना चाह रहे हैं तो आप क्रेडिट कार्ड से पे करना चाहेंगे कि आज ही पे करना चाहेंगे, कैश पे करना चाहेंगे, आराम आराम से पे करना चाहेंगे, कैसे पे करना चाहेंगे? तो ये क्या बता रहा है? पेइंग कंडीशन. दैट मीन्स इट इज रिलेटेड टू फाइनेंस. तो कैन वी प्रोवाइड नेम टू दिस फैक्टर फाइनेंस? कैन वी प्रोवाइड?
Yes, ma'am. Okay.
Second factor consists of 4 statements, which is telling good physical condition, dress for fashion, have stylish clothes, look different. It is related to, more or less related to appearance, fashion, style. So can we provide the second factor? Fashionable name. Can we provide the name to this factor, fashionable or stylish? Right? Okay. Let me ask from you. These all statements come under one head. Here is one. Fifth factor. It consists of 3 variables. Do something different, like to travel the world, try new products. Why are you purchasing the car? Do something different, like to travel the world, or try new products. So this fifth factor consists of 3 variables. So can we provide some name? Can you suggest some name? In EFA, we have to provide name, which is called latent factor. Initially, there was no name, but after applying EFA, we provide name to this factors. So can we provide name to this factor like I had done in the first and second factor? Can you suggest any name?
Taste and preferences.
Yes, ma'am.
These
Preference,
variables,
attitude.
these variables are related to you are going to buy a car just because you want to do something different.
Yes,
Like
taste and
travel,
preferences.
try new product. It is based on trial and error, right? It comes under this. Or you can provide name to this factor, last one. The last one is children are most important. Just children are most important. That's why I'm going to purchase a car. Or spend an evening at home.
Family preferences.
Family preferences. Okay. So in this way, we are going to provide names to the factors. Now, I hope the demo session of this EFA class is done and you understand all these things. Now, another thing is after this, we have to check the reliability. What is reliability?
Like every time results are same, na? We
It's
test,
also consistent.
retest.
When your scale is used by some other researcher, it should give the same result. This is called reliability, right? So reliability, we use Cronbach alpha. Okay. Now, how to use this Cronbach alpha? I'm taking the same data set. How to use this Cronbach alpha to check reliability? Can anybody tell where we can find this Cronbach alpha? Under which head? Any idea? Can you see this scale? Under scale option, just click on reliability analysis. Okay. Now, factor wise, you have to transfer your variables. Okay. So factor wise means I think I have closed that output. First we did dimension under dimension reduction. We have transferred all these factors, variables. So see, these are the factors. Rotated component matrix, use of credit cards, spend for day to day, like to pay cash. So all these 1, 2, 3, 4, 5, 6 variables need to be transferred for Cronbach alpha. Under scale, just go to reliability analysis and here's one. All the 6 variables you need to transfer. Use of credit cards. Like to pay cash. This is like to pay cash. Not heavily in debt. This is. Next is seldom use coupon. This one. This one. Interest rate, good physical condition. This one. And interest rate are low. This one. Okay. 1, 2, 3, 4, 5, 6. By default, the model is showing alpha value, so no need to change anything. Just click on OK. Just a minute. Just click on statistic tab, and under statistic tab, just mark on scale if the item deleted. Just click on this and then continue and then click OK. Now, to check the reliability, this is Cronbach alpha value. Number of items were 6. The Cronbach alpha should be greater than 0.6. Okay, minimum is 0.6 or 0.7 is better. Okay. The threshold limit is 0.6. If it is 0.7, then we can consider 0.7 or more. So it is more than 0.6, 0.848. That means it is satisfying the condition of reliability. Right? Any problem in this? Similarly, we can check reliability of other factors. Other factor is the second factor consists of 4 variables. So can we check reliability? Go to analyze, scale, reliability analysis, go to reset. And the second factor consists of good physical condition. Just transfer this. Dress for fashion. Just transfer this. Have stylish clothes. Just transfer this variable. And last one is look different. Just transfer this. Go to statistic tab. Scale. If item deleted, should be marked. Continue and then OK. What is the value of reliability Cronbach alpha? Is it acceptable?
Yes, ma'am.
As it is greater than 0.6. Okay. Now the question is, if Cronbach alpha is lesser than 0.6, then what we can do for this? Either you go for cleaning the data. If there are some respondents who gave 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, these are not engaged responses. So we have to delete these responses. We have to clean the data first. Or what can we do? I'll show you one demo. Going to close this data set. This one is this is another data set, and it will be showing the low Cronbach alpha values. How can we remove this low alpha Cronbach alpha values? Go to analyze, just go to scale and reliability, just check the alpha value first, and we have to check factor wise. So these are the factors which I have already made. These are the 7 factors. Just transfer this factors over here. 4, 5, 6, 7. Okay. Go to click on OK. The reliability is more than 0.6. Okay, it is acceptable. The second factor, just check for second factor. The next factors are anxiety. 1, 2, 3, 4, 5, 6, 7. Next 7. I have to transfer these 7 variables here. One, 2, 3, 4, 5, 6, 7. I'm going to transfer this. Let's transfer this over here. Click on OK. Again, the reliability test is satisfied for the second factor. No need to change anything. Check it for third factor. Go to reset. Our third factor consists of 1, 2, 3, 4, 5, 6, 7 variables. I'm going to transfer the variables of third factor. Again, it is showing proper. Let me check for other. Four variables are there. Computer use 1, 2, 3, 4. Let us check for this fourth variable. I'm going to transfer this and click on OK. Now the reliability is 0.691. Okay. It is acceptable, na? Still acceptable. One, two, three, four, five. Analysis, scale, reliability. I'm going to transfer this. This time. Let us check for next. Now, the reliability is 0.484. It is lesser than 0.6. Now, what to do for this? Here, when we check the reliability, scale, reliability analysis, statistic, under statistic, we have to mark on this, continue, and then click on OK. When we did this, all these things, so we came to know that reliability, the Cronbach, the value of Cronbach alpha is lesser than 0.6. Now, what we can do for this? Can you see this Cronbach alpha if item deleted this column? Just eliminate this highest, just eliminate the variable with highest value. Just eliminate this variable with highest value. Which is having the highest value, 0.616, we have to eliminate this variable. Analyze, scale, reliability. Which one we are going to remove? Excel help me recall information. Excel help me recall information. This one. Just eliminate or remove from here. And now check reliability. Okay. Can you see this? The value of Cronbach alpha increases. If still you are not satisfied, then repeat the same process. Which value is higher one? 0.695. Then we will eliminate this statement, this variable. We are not going to consider this statement. Under a scale, go to reliability. Which one? Excel help me in interpret data accurately. This one. Remove this and then go and click on OK. You can see the value of Cronbach alpha increases. Now it will be considered. It is a part of. These three statements are enough. Clear?
And does it mean that,
Yes, ma'am.
the responses are consistent?
Ma'am, please repeat the question.
I just wanted to know that does this reliability suggest that it is only
There is a problem in questionnaire or the responses which we got from the respondents, but not enough, but not valid. That's why we had eliminated these statements.
Yeah.
And after this, we can apply the CF.
Okay, so that means the responses are much varied. We
Yes.
can't form an opinion based on
Yes.
those.
Otherwise, it will be creating problem in CFA. So we have to make the data reliable first. So from our side, EFA is completed. Exploratory factor analysis is completed. We have shown you how the factors are formed and its terminology and how each value is related. Like KMO, what KMO value is stating, what Bartlett test is indicating. I hope it is clear.
Ma'am, we consider only independent variables now for
Yes.
extracting the variables.
Yes.
Okay, thank you. And those variables can be of any.
Even you
like
can take
any.
independent variable also. I had not taken, but we have to take. We have to take independent, dependent variable both.
So we can take both, है ना?
Both.
Could be of any type, na? Nominal, scale, ordinal, nominal,
only
ordinal,
scale data.
Only scale data.
Regression is applied on scale. Just EFA is applied on scale, Likert scale. All this process is done in scale data.
If data is ordinal, है ना? Likert scale.
Likert scale.
So then also we can apply factor analysis. Can we, ma'am, apply in ordinal data?
Yes, in my second or third session, I explained that some people take this 5-point or 7-point scale as ordinal data. Some people consider it as Likert scale. Generally, what statisticians are doing, statisticians consider this as an ordinal scale, combine together, make arithmetic operations over there, plus minus, and then convert it into scale data. But researcher point of view, we look out. So what researchers are doing? Researcher consider this ordinal data as a scale data. So
Okay, because mostly
both ways
question
are
here consist, of Likert scale questions mostly. So that's
Yes.
why I got a bit confused that can I
Yes,
consider
yes,
it as
yes.
scale
This is the
one?
common problem.
Yeah. Okay. Thank you.
Even I had got
So, ma'am,
confused with that. That's why we are taking these sessions, because we know that most of the things are there that are not explained by the supervisors or anyone. So we are taking this session so that we can know what exactly the data is, what exactly the data should be, and how to apply test on which type of data.
But you have cleared, ma'am, almost every doubts. No? The small
Yes,
parts na,
I
where
know
we
that.
used to get stuck. Na? Very well explained. Thank you so much.
Thank you so much. Any more questions related to this? From my side, the session is over. So we will be meeting tomorrow with new technique.
Can I ask you something? Yeah,
ma'am,
ma'am,
Madhuri is there.
can I have a question?
Yes.
Yeah, ma'am, for this reliability analysis, do we take only those factors which have similar responses, like either on Likert scale or any other type, but similar response scale?
Reliability means when your scale is developed, when your scale is used by some other researcher, he will also get the same responses. He will also get the same result. What you did in your research study.
Like, can I include the question which is open-ended, or a question which has just two
Yes,
responses,
open-ended you can include, but after this you have to, while feeding the data into SPSS, you have to convert it into close-ended as per after reading all the responses from the respondents.
Okay, all should be close-ended.
Huh.
Okay. Okay.
On that basis, you can convert these questions into closed one,
Okay.
close-ended question.
Okay. Thank you so much.
Ma'am, I think we have cleared all the doubts of the participants.
Yes.
Yes. So thank you, Dr. Priyanka Chawla, ma'am. Thank you, Dr. Samir Dubey, sir, for today's session. The session was really fruitful and interesting. And thank you, Research Foundation of India, for providing us this opportunity of learning. Thank you, everyone.
Thank you again.
The session is over.